Okay. Yeah, starting, so it's good. All right, here we go. Thank you. So laptops closed, please, if you're taking notes. Last time we met on Friday, we kind of started with this. We talked about the inverse matrix. Just real quick, if you take a matrix multiplied by its inverse, what do you get?
0?
You're going to get the identity matrix. So if you take some matrix by its inverse, you should get the identity back. And we left off on solving. There we go. So use the inverse matrices to solve systems of linear equations. You should already still remember how to do get an inverse and do all that good stuff. So we're just going to jump right into it. I'm not going to just have you look at this because this is mind-boggling, right? And then they want you to do that. So let's not. Let me just grab this example real quick. Silence. Did you like it? Okay. Okay. So you have a matrix, you have a system, and you want to solve this matrix using the inverse matrix method. Okay? I'm going to walk you through it. If there's any questions, please stop me at that point, and you can ask your questions. But you should already know how to do some of this stuff. It's not that difficult. I'm going to start by doing the coefficient matrix, which is, I'm going to call that A. And that is simply 2, -3, 1, and 5. Okay? And then I'm going to make another matrix. I'm going to call it B. This is matrix B. And you can't see me on the video do this, but I'm going to throw up some air quotes. This is the answer matrix. Okay? I'm saying that in quotes because it's simply the answers to these equations, right? Which are 1 and 20. But it's not really the solutions to the system. It's just the answers that they have given us here. So we know that 2x minus 3y is equal to 1. So I've got the kind of like the answers of the equations type thing. It's not really the solution. So it's not what the values of x and y are, is what I'm saying. Okay? Questions there?
Yeah, where'd you get the one? The one is the answer. Oh.
Okay. Anybody else? Yeah, don't get stuck there. Stop. Don't get stuck. I want to say stop. Don't be stopped there. No, but stop. Stop. Don't get stopped. Everyone cool? All right, cool. Let's do this. The first task is to get inverse matrix of this bad boy. So we're going to start with 2, -3, 1, 5. I'm going to write the identity matrix on the right side. What should that look like? It should be 1, 0, and 0, 1. And what I want to do is I want to get the left side to look like the right side, in this case, right? I want the left side to look like the right side. And how we do that is through row operations, okay? So, I want this 2 here to actually be a 1. And the way I'm going to take care of that is using a row swap. I'm just going to swap that. Because the bottom one is a 1, right? So I'm just going to use a row swap. So I've got 1, 5, 1, 0.
No, that would be 0, 1, wouldn't it?
Oh, thank you. I was looking at the wrong values. 0, 1. And then I'm going to write the top row at the bottom. So 2, -3, 1, 0. Questions there? We're cool with that row swap? Yay, I got a 1 there.
So you can just,
That's all we really did is we swapped the rows. What?
you can just swap them like any time.
Yeah. It's one of the rules. Swap rows, add to a row, multiply and add. Right? Or multiply. So it's 4 rules. That's it. Wow. It's pretty limiting. Okay. Now, unfortunately, that puts a 2 under here, doesn't it?
Yeah.
I want this 2 to become a Good, a 0. The way I'm going to achieve that is I'm going to take row 1, multiply it by a negative 2, and add all those values to row 2. So that gives me, let's see here, negative 2, negative 10, 0, and negative 2. Correct?
Yeah.
If you take all these values up here, Chase, and multiply them by negative 2, I get those numbers that I just wrote. Okay? Now what I'm going to do is I'm going to add them to row 2. Okay? Does that change row 1 in any way? Sure doesn't. So 1, 5, 0, 1. So here's what the next row looks like. 2 plus a negative 2 is 0. Negative 3 plus a negative 10 is negative 13. 1 plus a 0 is 1. And 0 plus a negative 2 is negative 2. Good. I need the negative 13. I need the negative 13 to be a 1 now.
Wait, why are you going to do that?
Because we do row echelon, and then we reduce row echelon. We row echelon, and then we reduce row echelon. Okay, so I want that diagonal of 1s with 0s under there first, and then I can worry about the top. Okay? So, the way I'm going to do that, and you're probably not going to like this anymore, but that's okay, is I'm going to multiply row 2 by negative 1 over 13. Right? That is the multiplicative inverse of a negative 13. Negative times a negative gives me a positive. And 13 over 13 becomes 1, which is exactly what I need to happen. So, there we go. Does the top row change in any way? So that's still 1, 5, 0, 1. Here we go. What's 0 times negative 1/13? 0. What is negative 13 times negative 1/13? Uno. Sounds like a lot of people already know how to do this. There's a lot of chatter from these rabbits out here. So, negative 1 times negative 1/13 is going to give me negative 1/13. And then negative 2 times a negative 2, negative 2 times a negative 1/13 will give me a positive 2/13. Okay, so right now we're at REF. We need to go RREF, right? So that 5, this 5 right here, needs to become a 0. Okay, now remember I do this in reverse. So I need to take row 2, multiply by negative 5, and add all those values to row 1. Right, Debo? Fractions don't scare me. I ain't scared of no fraction. I ain't afraid of no fractions.
You're a fraction buster.
Oh yeah?
No?
Here we go. So, I need new values before I do that, don't I?
Yeah.
So let's see here. Taking row 2, multiply. So 0 times negative 5. 1 times negative 5. Negative 1/13 times negative 5. It's going to give me, I'm combining them, aren't I? No, I'm multiplying. So that should give me 5/13. 5/13. Positive. And finally, I should get negative 10/13. Negative 10/13. Okay? Pay attention at first.
Is that a time sign?
Did you hear my
I am.
joke?
What?
I said, did you actually hear my joke?
No.
You were right.
Well, what's funny?
I said, you're the fraction buster.
Oh, I heard that.
Oh, your response made it sound like you didn't hear.
Oh.
Thanks. Pity laugh. Appreciate it.
I did hear that, but I was like, I was
didn't
already,
get it?
I was already beyond that. I'm sorry. So it would, I heard out of context now because I was already beyond it. It just didn't, it didn't flow. Yeah, so it was like, what's he mean? I'm like, okay, I see it now. My bad. Fraction busters. All right. No, I'm just like, man. It's fun. It's funny. Let's add them up. 1 plus 0. 1. 5 plus a negative 5. 0. 0 plus a 5/13. 5/13. 1 times a negative 10/13.
Negative 10/13.
Nah, 3/13.
But it's 1.
Yeah, it's 1. Exactly.
Oh, yeah. I see. Here.
Here. I'm adding 1 and that, correct? So what's 1 as a fraction with a base of, sorry, with a denominator 13?
13.
Oh.
13.
No.
13.
It's 13/13. Minus the 10/13 gives me 3/13. Welcome back. Welcome back. It's okay. All right, let's finish this up. Now, did the bottom change? No, it didn't change. So we've still got 0, 1, negative 1/13, and 2/13. Yay! We got the inverse matrix. Okay. Now, technically, we should check it right now.
We're not going to.
Why?
Just plug it in.
Nobody got time.
Go ahead. Guy, I can't hear these questions. And I think you have them too, so please listen. Go ahead.
Okay, so when you're getting rid of the 5, like, I don't understand how you come up with the equations, like how you know if you're timesing the number by row 1 or row 2. Like, I don't understand how you
So I was using this 1 as, because this is just going to be 0, right? So if I multiply 0 by anything, it's not going to change it. So if I can multiply it by something, it's still 0. And then when I add it to 1, it doesn't change. So you're going to be using that equation here to kind of work your way up. You do it one way on the way down, but then you do it the other way when you're working your way to reduced row echelon. So I was using the second equation. If I could take the second equation, multiply by negative 5, let's quiz. Let's quiz. Let me stop this recording. Sorry, whoever's online.